Ubiquiti recently had a Christmas sale on a bunch of their routers and access points, and I've been meaning to update my Aruba Wi-Fi system with one from Ubiquiti for quite a while. So I went ahead and pulled the trigger. But is this good enough to replace all of my network setup? I have a NetGate pfSense firewall that's an enterprise class appliance with a 10 gig internet connection. Is this router, the UniFi Dream Machine Pro, is this going to be able to replace that? Let's find out. So let's take a look at what this thing is first, and look at it in a context of the lineup from Ubiquiti, from UniFi equipment. The UniFi Dream Machine Pro is a rack-mountable device. It has two SFP Plus ports, which are for GBICs. You can put in modules for different kinds of 10 gig interfaces, and then it has 9 gigabit Ethernets. None of these are PoE, by the way. The throughput that's rated on the website, throughput's rated on the website as 10 gig, and IDS IPS throughput is 3.5 gigs. The sale price was $299. Normally this is a $379 box. So let's just take a look at the specs here. If we look at the other rack mount devices that are available from Ubiquiti, this is, I guess you could say, this is the smallest one. The slightly larger ones would be the Dream Machine Special Edition, which is exactly the same throughput specifications, but I believe it has an integrated hard drive. And the Dream Machine Pro Max is a slightly higher performance and also has some integrated PoE. So that's kind of the Dream Machine lineup. Then they have an Enterprise Fortress Gateway, which costs $2,000, which is actually a little bit closer to the model of NetGate that I have, and similar in performance specs from the looks of it too. This one's rated at a total of 25 gigabits of throughput with IDS IPS throughput of 12.5 gigs, whereas my existing firewall gateway from my network is rated at 19 gigs of throughput and 18 gigs or so of firewall forwarding. So there you have it. Pretty good spread in terms of pricing here, and I'm really anxious to see how this $300 box performs. So how are we going to test this? First of all, before we get into that, let's take a look at my home network topology that I have today. So my firewall up here, connected to the internet at 10 gig. I have an Aruba S2500, which is a PoE 48 port GigE switch that lights up my Wi-Fi access points and provides some other services on the LAN. And then my workhorse in the network is this Dell S6000, which is a 40 gig switch running Dell OS. And that's where all my lab servers are connected with 40 gig connections. So my thought here is, hey, this box, this pfSense box up here was pretty expensive. Could I just drop in the UniFi Dream Machine Pro to replace this in my configuration? My main concern at this point is not functionality, but it's actually performance. Is this thing going to be able to actually fill my 10 gig internet connection? So let's take a look at the logical topology on the network. It's pretty simple. I have a bunch of different VLANs. Some of them are completely isolated from the firewall, like my SAN VLAN that runs the drives and the Ceph cluster within the lab, but most everything else connected to the firewall. And my main VLAN is my DMZ VLAN, VLAN 1, where I've got DNS, Ansible, Home Assistant, and pretty much most of my VMs that I run in my Proxmox cluster. And then I've got 3 different VLANs that connect to the Aruba access points, a general home user SSID in VLAN 13, a guest VLAN on VLAN 14, and an IoT VLAN on 15. I also have a Aruba virtual mobility controller running in my cluster that sits on VLAN 13 as well, that that all of the access points talk to for boot up and control. So what are we going to run through today? Let's take a look at the plan. So we're going to look at test equipment that we're using. We're going to review our test topologies, both at a logical level and a physical level, so you can see what's going on with the cabling, but also the VLANs and how that's all set up. We're going to do some testing of our test equipment itself. And then we'll go into the results and look at some performance tweaking that I attempted to do to improve some things here and there or degrade things here and there. And then we'll, based on all of that information, we'll look at the design and implementation of this device in the network and a final summary. So let's get into it. Comparison on our test equipment. The enterprise appliance that I've been alluding to is a NetGate 1537. This device is no longer for sale. I think I bought it maybe 3 years ago, something like that. And when I upgraded my local internet from 1 gig to 10 gig, and this is running the latest release of pfSense 24.11, which is based on the FreeBSD 15.0 kernel. And from a CPU perspective, it has a Xeon D1537 in it. So that's obviously where the NetGate folks got the name for this particular appliance. It's the same as the CPU. This Xeon has 8 cores, 16 threads, and the base model, which is the configuration that I have, has only 8 gigs of RAM, which has proved plenty for my application. When it boots up, it says it has an Intel 552 10 gig interface in it, but the specs say that this is a system on a chip, so it's actually part of the CPU and the chipset that goes with the CPU, which having that level of integration could explain some of the good performance numbers that we get out of this thing. Now, the website says that from a forwarding perspective, it gives us two numbers, 18.8 gigs and 15.2 gigs. And the 18.8 is for large packet sizes, and then the 15.2 is for an iMix, which is to say it's a distribution of both large and small packets, which is a bit more realistic for performance testing. I will note that for the purposes of today, I've used a fairly simple test methodology with iPerf3 using TCP, which is going to be all large packets. So we're not really testing a distribution of packet sizes today. But for this test, I think that's going to prove fine and tell us quite a bit. It then gives some firewall performance numbers. The large packet sizes firewall is at 18.6, and then for the iMix, it's at 10.2. So the distribution of packets does drop pretty considerably, but it's also worth noting that there's a lot of rules in place for this particular number. They've said they've put 10,000 access lists on the firewall. And then run a mix of packets in order to get the performance down to 10 gigs. So that's still pretty good. I'm going off of memory here since I don't see a price on the website anymore. I think this device cost around $2,500. So this was definitely the expensive part of my 10 gig upgrade that I did. Now, I've always kind of wondered if I ran pfSense just as a virtual machine on one of my Proxmox lab devices, if this would be sufficient. All 4 of the devices in my Proxmox lab is Dell PowerEdge. 3 of them are R730s. One of them is an R630. And these are all dual Xeon CPUs of varying types because I bought it off of eBay, and varying RAM, anywhere from 128 to 384 gigs of RAM, anywhere from I think 36 CPUs up to 72 CPUs in one of the boxes. So in this particular device that we're going to be running the virtual machine on, this is a Xeon E5 2667V4, and we've configured it with 16 cores, which is really 16 threads. So it's a very similar configuration to the enterprise appliance, and we've set the RAM at 8 gigs as well. The network interface on this guy is a Mellanox Connect X4 40 gig interface. Picked these up off of eBay for $15. Nobody really likes 40 gig anymore, so they're cheap and plentiful. But they probably aren't the most performant NIC that you can get either. I think the Connect X5 has a pretty significant performance boost over the Connect X4. There is no performance rating available on the website for these because it's obviously hardware specific. And I'm going to put the value of the server that this guy's running on at somewhere around $400 for all of the parts, including a used enterprise SSD drive that I picked up off of eBay as well. And then for our star of the show, the UniFi UDM Pro, which I would put into the prosumer or small to medium-sized business class of product. That's running the latest UniFi 4.4.6. I was pleasantly surprised to find that it is running on Debian Linux, which is exactly the same thing that sits underneath Proxmox, and of course is the base for my go-to operating system, which is Ubuntu. So very familiar with all of the apps that are available and how to do additional administration on the command line. This also gives you access to containers if you want to run Docker containers for various types of applications right on the router. That enables that, so that's pretty cool. CPU on this guy is the ARM Cortex. This is a 4-core CPU. And it also has 4 gigs of RAM. I'm not sure if it supports threading, kind of like the Intels do, but this is the information that's available to us. On the NIC, this was a brand new name for us, Annapurna Labs, which is apparently a wholly owned subsidiary of Amazon. So that's what they've got in there for the network interface. And I think I mentioned this in the opening. The website for this particular device says that it is capable of 10 gigabits per second of throughput, but then it doesn't say firewall performance on the website. It actually says IDS IPS performance of 3.5 gigs. So what this tells me, or what I'm guessing just based on the website, is that if I turn off IDS IPS, I should be able to get 10 gigabits per second of throughput on this, which sounds pretty good for $300. So let's get into it a little bit further and see what we're looking at here. So here's how we're going to test this thing. First of all, the logical topology. We've got I actually have 5 different client devices, each one with exactly the same specs on Proxmox. They all are running 8 cores and 8 gigs of RAM. And there's 3 that are going to be specific to testing each one of the firewalls. They are connected on a dedicated VLAN that only touches that firewall. So we'll know for a fact that the packets going to each one of these individual test clients it has to go through that firewall. I then have a sinkhole server, which is connected to all 3 VLANs on the other side of the firewalls. And again, they're isolated. So each one of these VLANs is completely independent. There's no way for client 0 to get to the sinkhole server without going through VLAN 101 and the UDM Pro. There's no way for client 1 to get to the sinkhole server without going through our virtual machine pfSense device, etc. I've also set up just what I call client X and client Y. These are 2 additional clients that are sitting on the same VLAN as the sinkhole server. One of them is on the same device as sinkhole, and the other one's on a different device. That way we can get some testing that's completely independent of the firewalls. What that looks like physically is client X is sitting over here on Fjord Goal, same location as the sinkhole server. And client Y is sitting over here on Lock Goal, the same exact machine that all of the clients are sitting on. And then our pfSense virtual machine is sitting off on its own machine. So this is going to enable us to do some testing of the switch infrastructure some testing of VM to VM within the same server, and then as well as get all of our different router topologies tested. So how are we going to test this thing? So intra-server performance, we're going to run the two VMs on the same physical server. For the network test, excluding the firewall, we're going to be testing server to server. We've also done trace routes to make sure that there's no asymmetric routing. Going back to this diagram here, I did have to set a static route on the sync server. I couldn't just rely on a default route to make sure that the path. Once this client, for example, sends a packet out to sync, we want the return path to go through VLAN 102. That means that this interface needed a static route for the subnet associated with this VLAN to ensure that it went back through here. If I had done a default route, I might have seen all of the traffic kind of head over to the NetGate and then traverse over to these other devices, and that's not what we want. We want to make sure that everything always follows a nice symmetric path as you would expect here. And then I've put the test command in here. The test command here is iperf3 -C, and then that's for the client mode, and then the host that you're going to go to. So I had to pick either sinkhole 1, sinkhole 0, or sinkhole 2, depending on the exact test to make sure that it was hitting the IP address and interface that was directly connected to the firewall. Our capital P and 8 means we're going to use 8 parallel streams, and the -N indicates that we're going to be sending 100 gigabits of file size, which is equivalent to about 93 gigabytes. And then since we have not specified the -U flag, this is going to be using TCP. TCP on a local LAN with no latency in this environment and big window sizes is going to provide plenty of throughput compared to UDP. If we were doing testing like across the transatlantic or something like that, we might want to consider doing some UDP comparisons, but TCP is going to be just fine for our purposes here. So first of all, let's take a look at the intra-server test. So this is going from client X to the sinkhole, and when we run our iperf test, we get 53 gigabits per second, which is not bad. I kind of personally would have hoped and expected even higher performance since there's no network interface involved here at all. But 53 is representing server performance as well as Proxmox overhead and things like that on our VMs. But nonetheless, this does tell us that our VMs have plenty of horsepower for this additional testing that we're going to do. On our server-to-server test, the main goal here is to test switch performance as well as the Mellanox NICs and make sure that they're all up to task for the tests that we're going to be running. Since the UDM Pro and the NetGate are both 10 gigs, we would ideally like to see more than 10 gigs. We have to see more than 10 gigs on this test, or we're not going to be able to push our other devices hard enough. But also, it would be great to see this be as close to 40 gigs as possible, which would really tell us that we're going to be able to stress the pfSense VM as much as possible. But on testing, we found that we weren't even able to hit 20 gigabits per second. We came in just under 19 gigabits per second. So this would be the maximum performance that we could expect out of pfSense VM just based on the switch performance and the Proxmox cluster here. Finally, let's get into our first real test. Let's look at the enterprise appliance from NetGate running the latest version of pfSense Plus. This is going to pass from client 0 down to sinkhole 0. It's going to be going through both of our switches, our Dell switch and our Aruba switch. And performance test here was maximum, pretty much. We could maybe have squeezed another 50 megabits out of this thing, but honestly, 2.76 gigabits per second after you account for Ethernet overhead is pretty much the maximum that we're going to see on this. Let's take a look at our pfSense VM next. So in this case, the traffic is all staying on the Dell switch. And we're really hoping that we can get something close to that 19 gigabits per second that we saw on the client Y to sinkhole test. But no. The best performance that we saw here was 7 gigabits per second. And we are going to mess around with some settings and see if we can improve that. But right out of the box with the settings that we used on the Proxmox VM and everything and all the settings inside pfSense, this is what we ended up with. And then for the star of the show, the UniFi Dream Machine Pro. Again, in this case, the most that we could see is 10 and not about what we saw on the NetGate test, 9.76. It is rated at 10 gig of throughput. And we do have IDS IPS turned off for this particular test. And let's see what we end up with, under 4 gigabits per second. So this is more than the 3.5 gigabits per second that was indicated for IDS IPS throughput, but quite a bit less than the throughput rated on the website. So that is pretty disappointing. I don't know. We're not going to be able to use this device the way that we had hoped, replacing our enterprise appliance. This is still really good performance. I don't want to, for $300, this is actually really great, but it's not going to be a replacement for our network appliance. So let's talk a little bit about what we did on the performance front. So first question you might ask is, well, what if we increase the number of cores for the virtual machine on Proxmox? And we increased it from 16 cores to 32 cores, had no impact. We did find something online that suggested that the VMware compatible network interface might perform better on FreeBSD. That's VMXNet 3 in the interface there. So we added a couple of those interfaces and tied them to the VLANs and reran the tests, and we actually saw much worse performance than the default VirtIO drivers, which suggests that in FreeBSD 15.0 there is a highly performant native driver for the VirtIO drivers in there. The VMXNet 3 was a bust. We disabled the Proxmox firewall, so there's a built-in firewall in Proxmox, which is very handy, by the way, but we don't really need to have that on top of a device which is already a firewall. So that was disabled for these tests. There is for the VirtIO drivers, there is a multi-queue setting, which we had set at 8. And last but not least, the MTU on all of the network devices was set to 9216. That is for all the firewalls and all of the switch ports, 9216 jumbo frames everywhere across the lab network and the internal network. And then the Proxmox VMs themselves are set to an MTU of 9000. So that would be the Proxmox NICs, the bridges, the Linux bridges that are configured in Proxmox, and then also at a system level, the pfSense is set to 9000 MTU, and also each of the clients and the sinkhole, all MTU of 9000 across the board. So, another thing worth mentioning is that within pfSense itself, there are also some settings that you can apply that pertain to offloading certain things onto the NIC. And I won't go into those settings here because I tweaked a whole bunch of those settings and they had no impact on the performance, plus or minus. So as far as I could tell, they weren't even connected to anything on the operating system. It basically did nothing. I'm sure there's cases where they would come in handy, but in this case, they didn't do anything. So on as far as our performance tweaking, trying to increase the performance of that pfSense VM, I had no luck with any of the tweaks that I tried to make in getting the performance above 7 gigabits per second. Well, now let's talk about degrading performance. So we already had everything turned off on our tests of the UDM Pro. Now let's go turn on IDS IPS. And here's where you would do that. You go into settings, and then you go into the cybersecure tab, and you can flip the switch for intrusion prevention. That's your IDS IPS option that exists in there. And it doesn't have a ton of rules built in by default. You can see down below the number of signatures that it has. It only has like, it looks like, what is that? Maybe a couple dozen, 2.5 dozen different signatures in there for intrusion detection. So not a ton. That can be expanded with a license, which I'll talk about a little bit later in the presentation here, but not a lot of signatures. But we'll go ahead and with this turned on, we're going to see if the performance drops to that 3.5 gigabits per second. And it's pretty much the same test. This is just to remind you what the physical layout looks like. And we run the test, and it's only 100 megabits per second less. So it's essentially the same. We saw no change in performance by disabling or enabling IDS IPS. It's pretty much the same. So this is hopeful. This suggests that I can use the advanced features of this device for my Wi-Fi users without substantially degrading their performance. This also suggests that if you were thinking of getting anything bigger than the U7 Pro, like say the U7 Pro Max Wi-Fi access point, which is a 10 gig connected access point, there's really not much point in getting access points that are that fast, especially with the security enabled. It's not going to really run at full speed through this particular device. We might have had better luck if we had gotten the UDM Pro Max, which was rated at 5 gigabits per second of throughput with IDS IPS. But on this particular device, I think the U7 Pro, which does support 2.5 gigs, I think these devices are going to be just fine for this particular architecture. So how am I going to deploy this? I think I'm going to do a sandwich architecture here. So I'm going to leave my my NetGate appliance in place, running my 10 gig internet connection and supporting VLAN 1 with all of my default VMs so that my lab environment still has full 10 gig access to the internet and access to all of that bandwidth. But then I'll take all of my Wi-Fi stuff and I'll move it down to the UDM Pro. That includes that'll be the gateway for all the VLANs, so that'll get moved from the pfSense device down to the UDM Pro. These devices will also be doing DHCP for the Wi-Fi network. And then I'll turn on IDS IPS, and it'll be monitoring for malware and all kinds of stuff on any Wi-Fi connected device, which is going to be pretty cool. So just to summarize here, on the strength side, I would say that on a price per performance basis, $300 for 4 gigabits of throughput is actually really amazing. That's a very, very good amount of performance for the price. Is it worth spending 10 times as much to get a little over twice as much throughput? You be the judge of that. For me, I still like to be able to access the full 10 gig that my internet provider has. I'm going to be happy enough keeping that more expensive enterprise appliance as my main gateway. But again, $300 for 4 gigs of throughput is pretty amazing. Also say too that the Ubiquiti UniFi devices, they're known for their features, and the device is very easy to set up and has a ton of features. We didn't review any of those features today. I'm going to start picking some of those apart once I get my access points up and running. We're going to do some compare and contrast between the what the Ubiquiti is able to find on my local network in terms of intrusion and malware and stuff like that, compared with some other open source tools, so you can get a sense for that. But the features are pretty great, and the fact that it runs on Debian Linux is also great. I mean, that gives you the ability to extend the your use cases on your router quite a bit. On the negative side, uh, again, we were pretty bummed that we couldn't hit 10 gigs of throughput on this as advertised. But as noted, for the price, it's still pretty great, and it's still going to allow us to have a dedicated Wi-Fi access point controller as opposed to running it in a VM in our lab cluster, which by and large has been a very stable way to run my Wi-Fi network, but I think I'm going to be a lot happier having a dedicated piece of hardware do this, as well as to leverage the security features. There is I mentioned before the Cyber Secure Enhanced license, which leverages Proofpoint and Cloudflare. Now, I will probably give this a try. It's only $100 a year, so it's not a crazy amount of money. But obviously, I'm gonna try it out and see if it's actually detecting anything more than what I can already detect on the local LAN before I really commit to this long term. Again, as we noted, there's like 2 to 3 dozen signatures that are included. This Proofpoint license that comes with CyberSecure Advanced offers 95,000 signatures for detection and will automatically install another 30 to 50 signatures every month. So that would, in theory, keep you much more protected and give you more visibility into compromised machines on your local Wi-Fi network. I mean, this day and age, that's probably worthwhile to have that level of security, but obviously only if it works. So I put this as a negative, just because I'm pretty sick of having to sign up for annual subscriptions for everything, and maybe you are too. But we'll see if it's worth the money or not. And then last but not least, the applications that run on the UniFi platform, everything within the user interface, it is kind of some of it's open source under the hood, but by and large, it looks pretty proprietary to UniFi. They didn't use a bunch of stuff out of the box, and that is a bit of a downside for me, in that we're completely dependent on UniFi to roll out new features and capabilities in these set of devices. Whereas with pfSense, if when the community comes out with a new version of Snort or CARP or FRR or NetFlow, these versions are integrated relatively quickly into the pfSense platform, so you get ongoing updates across the entire software suite. So I kind of like that better in some respects, but sometimes you actually do get better features with proprietary software. So once we get into more of the feature testing, we'll see if I continue to think about that as a strength or a weakness. Well, that is it for today. If you've watched this far, thanks so much. Give us a like and a subscribe. Share it with somebody who you think it would help. And if you have questions, please do leave them on the video. It not only would it be my pleasure to answer those questions, but it's really great for the algorithm to help expand reach as well. So thanks again, and we'll see you on the next video.